Welcome, everybody, to the Making Awesome podcast. This is, episode 197? Yeah! Getting close to that 200 mark. I already reached out to Frankly Built to see if he wanted to come and hang out with us on number 200, because he hung out with us on number 100, so I thought it would make sense. But yeah, welcome to the show. We're going to be doing some diving into materials here in the next couple of weeks, right? We've got some guests lined up on both the resin and the filament side to kind of talk about not only how it's made, but like why different materials do different things and that kind of stuff. It's come up a lot, right? Nathan Builds Robots did that carbon fiber video, which is apparently surprising to people. I'm not exactly certain why that video is actually surprising to people, because it's not surprising to me. Anyways, hello. Welcome to 197 of the Making Awesome podcast. Got some awesome people here hanging out. Max H was here very early, like within a minute of me posting the actual stream, he was already in here hanging out. John Olson, Sound Spark, Spectre V3i, Miss Amber B, David Connor Shover, Geek Toy Box, Matrix Tech, James the Printer, and I think that will about do it. We do have, of course, a giveaway for printed solid filament, the Jesse line. It is in that pinned chat message, so go under for some free filament. Shipped free in the continental United States. If you are outside of the continental United States, you can either pay for the shipping to get it to you. You can get a free t-shirt, which does come out of our pocket, but hey, want to make sure that, people can still get things. Is something going on with the stream? Something wrong with the stream? See what's going on here. Is it not getting video? Because I don't see video. Do you guys actually see video? Okay, there. Now I finally see my own video. That's weird. Wait, does that mean it just started? I'm so confused. Have you all been hearing me talk for the last, 4 minutes? At all? Or have you all just missed it? Because now I'm curious. What? It's been streaming on my side for 3 minutes and 11 seconds counting. That's really weird. That's going to be a YouTube thing. I have not actually dropped a single frame yet, but the day is still young. Well, that's weird. All right, I guess I get to redo all my intro stuff. Hello, everybody. Welcome to episode 197 of Making Awesome Podcast. We're going to be talking kind of about the basics of filament and resin, just the basics of materials for 3D printing and why, well, you might actually like it raw. I'm just going to leave it at that. Late entered mid-word as usual. That's just how it goes sometimes. That's so weird. I will have to figure out why it's doing that. I think that's a YouTube thing. Anyways, got some awesome people here hanging out whose names I get to go through once again. Max H, John Olson, Sound Spark, Spectre V3i, Miss Amber B is here. David Connor Shover, Geek Toy Box, Matrix Tech, James the Printer. Did I say David Connor Shover? I think I did. Who else we got? Logic No. Steve Builds is here, who of course we're going to be sending you to when we're done with this, assuming I get the link right, because that gets messed up. Josh Edlin is here. Seabass, Reth, Jazz Cabbage. That's a great name. Cheesy Potato, Steven Z, Russell Milliner, sure, and Logic No. Thank you all for coming out. Like the stream, as always. Go ahead and sign up for the Printed Solid giveaway. Links are in that pinned comment here in the chat. Oh, look, I'm already dropping frames. Spectrum. That's so weird. Actually, while I'm thinking about it, I'm just going to go ahead and start a new latency test while we're streaming. Anyways, so a lot of you probably saw the Nathan Builds Robots video all about carbon fiber, and apparently a lot of you were surprised. I laugh because we talked about this years ago. Like, it was within the first 20 or 30 videos that we ever posted. I talked about the issues with fiber-filled filament and that it's just chopped and thrown into the filament. Now, Nathan used a sample size of 1. While I'm not saying that his test is not relevant, I think it's completely obvious. But I think the long strand carbon fiber companies, the ones that put much longer strands of carbon, you're not going to see that as common. But it does kind of bring into play the problems that we have here in this industry of, well, just a basic lack of understanding of material sciences, and even further, a basic lack of understanding of PPE that is required for it. The fact that Nathan used his own finger to show us all of that made me cringe so hard because it's dangerous. I understand that you need something to show for a video, but like, there are so many analogs for human skin out there. Go mix up some gelatin, right? It'll be good enough. Get something that's trying to think of, like, I have some tape measures that have a ton of silicone on them. That would have been fine too, without having to embed carbon fiber in you. But and that video's actually done really well for me. It's at like 70,000 views last I checked. So as far as content creation goes, that was a great video. And of course, it did really well, got featured on Hackaday and everything, but that is actually not the impetus for this. We've been trying to get Mitch from Polar 3D to come and hang out with us, and timelines haven't worked. It might actually be his birthday today, and speaking of which, I do need to wish Max H, Max H's daughter, Melissa, a happy birthday today. He did let me know that it was her birthday, so I wanted to make sure that we got that in there as well. So happy birthday, Melissa. If you all have missed, we actually called my grandmother on the Wednesday stream because it was her 94th birthday. We called her live. That was a ton of fun. She was very happy to hear from everybody. Yeah, I'm going to dig into filament for the most part because resins are not 100% my thing. I've asked Mayor Makes, and we've also asked, haven't technically asked yet, but I will be asking Goobertown Hobbies if Brent wants to come and hang out and talk shop about, the actual chemistry side of resin. But Mayor Makes appears to be down. We just got to kind of lock in a date for that. But I am more kind of understanding on the FDM and FFF, the filament side of things. I think a lot of you, that is the bulk of what you do as well. So I'd like to kind of play in that realm for at least right now, if that works for all of you. Here is the cat. Miss Vicky, are you going to grace us with your presence today? Are you going to grace us with your presence here on the stream? Is that what's going to happen? Are we going to have a good stream because of you? Just your head and your tail? What are you going to... Come on. Your bed's right here for you. You can go right into your bed. Please. Look. See? You guys get cat today. I mean, come on. How often does she actually show up in videos anymore? Nima Problema says, yeah, I mentioned it was Nathan Builds Robots that did it. I'm glad that someone is talking about it, but I'd be curious, and I have a lot of carbon fiber, so we're going to look at doing a similar test, but with lots of carbon fiber filaments that we have on hand, some of which that have like real certifications and stuff with them, right? Because when you're printing a lot of these carbon fibers and everything, certifications are often what you're looking for. Chaz Cabbage says, I've had much worse things on and in my hands than a little carbon fiber filament. But that doesn't mean we should be nonchalant about the actual PPE around it. Let's talk about the basics of materials, though, and we'll get into some carbon fibers here in a bit. But let's start with, like, the basics of filament printing, right? What are kind of the main materials people start with? It's PLA, PETG, ABS, ASA. Maybe you play with some TPU. There's some silk filament in there as well. But let's go ahead and start with PLA. Right? PLA is the most ubiquitous filament out there. It is a corn-based. A lot of people like to say biodegradable. It's not. We have to look at. We have to kind of look at how we define biodegradability, right? PLA can biodegrade, but it has to be under like ideal composting conditions. Otherwise, it doesn't really ever break down, right? It needs pressure, it needs heat, it needs moisture, it needs a perfect environment for it to break down. So I'm going to consider PLA non-biodegradable just for the purposes of this talk. I think it's more valuable to look at it as a plastic than to look at it as, you know, oh, it's a recyclable plastic. If you want a truly biodegradable plastic, PHA is out there, and I have a roll coming from Polar. They made some test spools with PHA. It's just pure PHA. So I have some PHA coming, and we're going to be running some tests on that. And I'm interested to see it because I know some companies will add PHA as a blend, but often we find that like talc is one of the main blends in PLA to make it print faster. Now, we're kind of looking and I'm still in the like, you know, brainstorming stages of it, but a video on comparing fillers inside of plastics, because, you know, we have PLA, but then there's PLA Plus, PLA Rapid, PLA Pro, PLA Pro Max, I'm sure, because everyone loves the actual like Apple system for naming schemes, which I personally am not fond of. But we don't really know what all of this stuff is that we're running through our machines. We know that PLA Pro is generally more temperature sensitive or more temperature resistant. We know that PLA Plus often is temperature resistant and it might be high flow. High flow PLA is a little bit different. Cheesy Potatoes has tough PLA. Yeah, there is so many different variants, and some of them are just BS names, right? Some companies just call tough PLA regular PLA because regular PLA is actually pretty tough. It's one of the tougher materials that you can print on a consumer grade 3D printer without doing pretty much any upgrades, right? Off the shelf, you can print PLA, and it is a very strong material. The problem with PLA is that it has a very, very low softening temperature where, you know, around 100 degrees Fahrenheit, it will start to get a little mushy, but at 160, 140, 160 degrees, around 65 degrees Celsius, it's starting to become liquidy. And you can use that to your advantage. We've used it plenty of times to our advantage when we need to do parts with a slight bow to it. And we're like, we're going to print this flat, and then we're just going to bow it later on. Just go put it on the dashboard of a car and the floor to heat. It'll soften up. It always does. But then, as Nema Problem says, the tricolor silkies, the one that have sparkles in it, but the sparkle ones are actually pretty easy. It's just glitter thrown into the filament. And the glitter does the same thing that the carbon fiber, the glass fiber, and all of those do. It's an additive. And unless you're using that additive package that is also somehow chemically bonding itself to the plastic, you're just removing plastic and replacing it with this filler material. That filler material may or may not have impacts on your actual printing process. Cat, my leg was itchy. You don't have to just jump up like that. Come on. Also, give a like for the cat. I mean, how awesome is she? And the answer is incredibly awesome. I will accept no other answers. Cat shirts coming soon. We might have to delay. One of the samples that we got in from the manufacturer did not fare well at all. Like, it is already starting to fail. So I don't know what our plan is. Filthy Phil says, unlike for cats, I'm a dog person. Well, see, I also like dogs, but I prefer cats. You can like both. And how can you not like this cat? She's wonderful. She's perfect. Nothing else you could ever ask for. But PLA does have that big limitation of the temperature. And that temperature limitation is particularly an issue, especially now with temperatures on the rise. I mean, we've had record-setting heat around the world pretty much every day for the past few months. And that is likely not going anywhere anytime soon. And this time next year, it could theoretically even be more uncomfortable. And that means that more and more people are having issues printing PLA indoors. Those of you that don't have central air conditioning and you're dealing with high heat, I'm sorry. I wish that was different. As someone that lives in an area that is incredibly high heat, incredibly high moisture, but we do have central air, at least I'm not too sweaty indoors. But if you do get too high of an ambient air temperature, your PLA will start to fail. At around 40 degrees Celsius, PLA will start to heat creep and not move through a hot end very effectively. Hilariously, it does a lot better through a non-all-metal hot end at higher temperatures because that PTFE can actually insulate the filament itself from those kind of nasty ambient air temperatures. Are you going to jump down, Miss Kitty? Okay, there you go. Enjoy. Have fun. Go doing, I don't know, cat stuff. But that's where the non-all-metal hot ends actually win, because they don't have such an issue with heat creep because of that PTFE liner, right? And since PTFE, not only just a forever plastic as far as I'm aware, but it also self-lubricates, you get less issues with plastic having heat creep on these non-all-metal hot ends. So it's funny, the Gen 1 Ender 3 actually has value these days, you know? Which I think is hilarious. Also, when was the last time you had a drink of water? Hydrate. Dark Third Dimension says, laughs in Scottish at people complaining about living in a hot country. I mean, what is it right now? My computer says very hot weather. So that should kind of give you an idea. But I'm showing 93 degrees Fahrenheit, which is... I honestly have no clue what that is Celsius. It's not cold. I'll tell you that much. It's hot as sin out there. But part of the thing is just it's the humidity too. But yeah, right? With PLA, you have to be worried about your ambient air temp. But as a material, right, PLA is quite strong. This is going to be for an upcoming video. Actually, it's for Wednesday's video. I still need to film Wednesday's video. It's about 34°C. Okay. Cold front in NorCal. It's about 63 Fahrenheit. Well, that sounds lovely. This, you want to see something interesting? This is PLA. This is also PLA. These are the exact same color. The difference is that this one was accidentally printed at PETG temperatures. So 250 on the nozzle versus 215. And for a translucent plastic, that is much nicer. It is much prettier to print them incredibly hot. It was totally a mistake, and by the time I realized it, it was too late, and the parts were looking beautiful. So I said, well, screw it. I'm just going to see where this plays out, because why not? And so PLA is great for those static loads that aren't going to get a lot of heat, but you need that rigidity and stiffness. Now, for a lot of those people that are dealing with those high temperatures, we recommend going up to PETG. While it is often a little bit more expensive, although if you get it from today's Filament sponsor, Printed Solid, who of course has an ongoing giveaway, links are in that pinned comment, it is the same price for PLA and PETG, and at less than $20. I mean, it's a little over 20 with taxes, but it's $19.99, okay? It's $20 a kilo in the United States, made in America. That's tough. That's tough to find those kind of prices. And so we love Printed Solid and thank them for sponsoring the filament for this channel and sponsoring us the ability to give away filament to you all. Again, to enter continental United States for free filament, if you want to pay for it to get it outside of the US, you can. It's all explained in the actual thing, so enjoy. But ultimately, PETG to me is that kind of mix between the PLA and something like an ABS. It's better at handling heat. About 85 C is when PETG starts to get a little soft and molten. Technically, it doesn't have a glass transition temperature because it's an amorphous plastic. But, you know, whatever, right? People look at TG and they understand what it means. So a lot of companies publish a TG, even though technically it doesn't have a TG. I don't want to get into that because I'm not actually a material scientist. I'm just a persnickety pain in the ass on the internet. But I like PETG, but the problem with PETG is, especially with smooth PEI build plates and glass, it can weld to them. So you often have to have some sort of barrier. Traditionally, people use glue stick, and you might say, but Grant, glue stick is to make things stick better. And I would argue and say that it's not. It's not. Glue stick is a barrier between glass, PEI, whatever, and your part. It is likely not going to have any better stick than your part itself. If you are utilizing glue stick to actually stick things down in the 3D printing industry, clean your dang build plates, you filthy animals. Because damn, PETG sticks to basically anything these days. And unfortunately has a nasty habit of sticking too hard to those things. That's why we use barriers like the glue stick, although textured build plates are also known to work quite well in those cases. PETG has the one downside of starting to warp a little bit. It's nowhere near as bad as something like a styrene, like an ABS or an ASA. However, it does still work, especially on large, flat, thin parts. It has a tendency to warp because, like a lot of plastics, as it cools, it solidifies. Something to note there. Or as it cools, solidifies. No, as it cools, it shrinks. Grant, get with it. I got brain fog today, guys. I'm sorry. I am... this is a little personal, but hey, whatever. The meds that I normally take are once again out of stock and impossible to find. So I'm having to switch. I don't like it, but if I want... I have to slowly go off of the old stuff and onto the new stuff. You don't want to just like cold turkey, medicine. But it's a pain in the ass that generic medicine is not being manufactured or is in such high demand, and the companies appear to just be, I don't know, limiting a generic supply. Like, I have half a brain to just build my own chemical company to make this medicine because it is stupid. Anyways, Emo Problem says good PETG prints are just so damn slow. No, they're not. I can print PETG almost as fast as I can print PLA, and I'm talking about the raw stuff. Once you start mixing fillers and binders and additives and that kind of crap, all of these like technical discussions get thrown out the window because there's no way to compare the two side by side. It's like recently I got some Elegoo Rapid PETG for a project at a client's request. That is what they requested. It is not my preferred, and my God, it sucked to print with. It was not... First off, the Bamboo hates it. No matter what I do to that spool, the 4 spools that I've had, it does not work in the AMS. I put rings on it. I've tried weights. It doesn't like it. For some reason, it is not AMS compatible. I don't know why, and that upsets me, because regular Elegoo spools are, but their Rapid PETG has been a real bear for me. But it also wants to print considerably colder. Right, so we're running high flow on the Bamboo. And I'm going to use the Bamboo as the example because it's one of the machines that we have a high flow nozzle on that we use constantly with high flow nozzles. So I can run and often run PETG around 30 to 32 cubic millimeters per second. When we look at PLA, we can run it closer to 40, 45 if we're really pushing it. But once you start getting up into the 40s, you're running out of machine, right? You're simply running out of what the machine can physically do. to get there. And sure, you can increase your temperatures all freaking day to give you more flow, but you're non-uniform heating your parts, and that is going to create more of an instance where parts will start to warp. If you print slower on any material, it has less likely of a chance to warp given correct settings. I'm not a huge fan of filled materials. You might say, I like it raw. I'm going to clip that because I know the editors are going to enjoy the hell out of that. I found that the Elegoo Rapid PETG wants to be at like 240C when we're moving at like 30 cubic millimeters a second, which is just insanely low. For comparison, Polymaker PETG wants to be at like 265 to 280, and the Jessie PETG, which is still my favorite PETG to this day, is good at about 260, 265, so it's somewhere in the middle. Now, does that mean that Polymaker is somehow adding filler? I don't have an answer to that. I want to test it, but to do it properly, I think we really need to get a laser mass spectrometer or get access to one. I definitely can't afford one, but if you do want to support the efforts that we do, and maybe trying to convince someone to let me play with a multi-million-dollar, or at least multi-$100,000 laser mass spectrometer, you can subscribe, leave a like, join on Patreon, PayPal, channel members, all those places, you know, the normal places where you support creators like us that you enjoy. So we got 50 watching, only 23 likes. We got to pump those likes up. Those are rookie numbers and such. Seabass says, I have some glow-in-the-dark PLA that just refuses to stick to the bed. Normally, I had to lower my nozzle to make it stick. I really hope you're printing that out of a hardened nozzle, because that is a great example of a material that you wouldn't necessarily think is dangerous for nozzles, but it is. Traditionally, the glow-in-the-dark is strontium aluminate, I think, which is abrasive, so you want to make sure that you're using a hardened nozzle, and if you're using a brass nozzle, you will need to replace it after pretty much every single print. It will wear it down very fast. And you could use a Diamondback nozzle if you wanted to spend that kind of money. They were previous channel sponsors, and we are working on a really, really cool project for Diamondback. They don't even know about, because I like doing those things. But yeah, some materials like it hotter, and that leads me to believe that whatever Elegoo is putting into this material to make it rapid has a very, very low melting temperature. What is it? I don't know. You could do a burn test and effectively weigh what's left over and try to figure it out based on density, but just, ugh, it is very complicated. And outside of my range of knowledge, right? My range of knowledge is very much more on the mechanical side than the chemical side. I have some chemical experience, but that is specifically on making my own cyanoacrylate, otherwise known as superglue. So I have experience making that. In fact, we used to make drums of it when we were in the full color 3D printing industry heavily. Because it was very expensive to buy it, and it was considerably more affordable to make it. But there were a couple of times we might have gotten the mixture wrong and it cascade cured, and yeah, when CA starts to smoke, it's time to leave. TLDR. As Geek Toy Box says, I love having diamonds. I don't have to think about what I'm sending through my printer. It's absolutely true. I 100% agree with you. I can just send it. Now, the only thing I do have to think about is lowering the temperature a little bit, because the diamonds obviously do have a better thermal conductivity, which means they can handle a lower temperature. But as Seabass says, funny enough, I believe glow-in-the-dark is more abrasive than CF. I believe it is as well. But it often has to do with the amount of filler that is added in. How much strontium aluminate? How much carbon fiber? If you put carbon fiber through a 0.4, you're likely going to clog it. That's just the way this goes. There aren't good ways to stop that from happening. It's life, especially if you're using good carbon fiber filament. If you're using cheap carbon fiber where it's more of the powder that's thrown in rather than long strand fibers, you can probably get away with a 0.4, but we normally recommend at least a 0.6 Really, you could go down to a 0.5 if you wanted to take a risk, like use one of those Basel nozzles that the Basel people continue to harass me about. It's harassing with love, okay? It's not like nasty harassing, but it's harassing with love, as I'd like to say with the Basel company and the fanboys for the Basel nozzle. But you could go down to 0.5, but I say 0.6 or 0.8 is going to be on the safe side, and you'll have way less issues with clogging. So something to note. I would be curious to see if the Diamondback nozzle keeps some of those fibers from the carbon fiber from coming out, because it does also smooth those top surfaces. So these are all questions that I don't exactly have the answer to, and until I can insulate my garage, are going to be unanswered questions, because I don't have... This room is 170 square feet. It is incredibly tiny for 28 3D printers, so I don't have space in here to do like actual testing. It has to be done in my garage. But with it being now 94 degrees Fahrenheit outside, around 35 degrees Celsius, I'm not doing it outside, because if it's 94 in my 94 outside, it's probably at 100 plus in my garage. Rose Kindred says, 28 printers, no need for heat in the winter. I live in Florida. There is no need for heat in the winter. Period. Hilariously, unfortunately, the winter time is often our slow season, because companies are doing their end of year stuff. If they had big orders, they placed them in. Because like for Florida, it's like January is the cold season, right? Or a couple of weeks in January, it gets kind of cold. So I often don't have the 3D printers to warm the house up, but you can put more clothes on. You can only take so many clothes off before your channel gets demonetized. Science. What is heat? It is an absence of cold. Right? Although I guess cold is an absence of heat, technically. Let me see. We had some questions. I've used a 0.6 Diamondback with carbon, and it works great. No issues. Yep. Diomeda says, hey, Basil's mentioned. I have 2 waiting for my V-Core 4. Steven says, my old nozzle had a burr on the inside brass, so I use glow to clear it. You probably also turned your 0.4 into a 0.6. David says, I've been running a recycled PETG lately that turned out to be very incompatible with 0.4 volcanoes. I find that recycled PETG is a much more difficult material to print than regular PETG and needs way more kind of, I don't know, attention than regular PETG. But then we look at the styrenes, right? ABS and its weird uncle ASA. Now, I firmly believe that no one really should be printing in ABS when ASA exists. It doesn't smell as much, it doesn't warp as much, and it is UV stable. There's no reason that we should be printing with ABS anymore because we have ASA. ASA is just better, in my opinion. I don't know from a chemical standpoint why you would choose ABS over ASA. I know why it's chosen in manufacturing, and that's because, well, it's cheaper. And while, yes, technically ASA has less color options, as Seabass says, back in my day, we had black, white, gray, and natural, and we were fine with it, right? Like, just, I don't know. People's obsession with color today has been kind of an odd one. Because, of course, from reel to reel, a lot of companies don't have good consistency. I will say Printed Solid does. After making our own filament at Printed Solid, seeing how they do it, their consistency for color is very, very good. But yeah, back in the day, dude, if you wanted any color other than like a black, a white, a gray, or a clear, you were paying quite a bit extra to get it. Because it wasn't, stuff that companies made. Cheesy Potato says that they heard ASA absorbs more moisture than ABS. I really don't see that being a problem. I don't think either absorb a lot of moisture, so it's not that big of a deal. Berlin says, what's your opinion for the cheapest but good ASA? Stop looking at cheap. This is not about cheap. You look for what makes sense for you, right? Now, Printed Solid does not currently make styrenes. So I can't recommend them. I would if I could, because I love their other materials and I would be buying their materials. But often, most ABS and ASAs are going to be equal. If they're raw material, right? They're not recycled. There's not like random BS. All things equal, the filament should be relatively similar, right? I haven't had many issues with Polymaker personally, but I find their filament to be incredibly expensive for something that is imported. They make good quality stuff, but I can get better quality. Well, I can get as good, if not better quality from printed solid for less money. So, I don't know. BLD0550 says, does printed solid use cardboard spools? No, not anymore. They used to, they don't anymore. Their biggest issue is sourcing. Their manufacturers that they get the cardboard spools from have had issues maintaining the stock and inventory that printed solid needs. So no, they're going back to plastic. As long as you have good plastic recycling near you, and I'm not going to start getting on this tangent that plastic recycling is not normally recycling anyways, but whatever. You know, you will run into plastic spools. To me, have a lot of extra value. Cardboard is great because you can just throw it away and not have to care too much about it. But I can normally get rid of all of my plastic spools every holiday season, right after the holidays, to people that want them for cord reels, holiday lights, that kind of stuff. And as Dirdackle says, yep, in EU, you might as well just go with Filament ASA. So, and you're right. If you are in the EU, Prussia probably has much more affordable filament. So, but it is very difficult for a lot of these companies to compete with, you know, the companies coming out of China who are making filament for pennies on the dollar. Just be careful. Don't cheap out on stuff, because if you could buy filament for $8 a kilo or buying it for $20 a kilo, but you were going to struggle with the $8 a kilo filament, is it really worth the $8? I would argue that it's not. I would rather spend more money to get a product that I know works. That's my personal belief on it. Anyways, I'm tangenting. Steven Z says, hey, 3D Musketeers, if I'm printing a mount for a Starlink dish to mount to an RV, ASA should be the best filament pick, right? Or should I go with PC or something else to have weather resistance? ASA is UV stable, so it should be fine. But I would not also drive with the Starlink dish mounted, right? The mount itself, so if you take the Starlink dish off when you're driving, the ASA mount should be fine. I would worry that depending on how that dish is facing, it may create a lot of either downforce or just load that the part wasn't designed to handle, and would cause it to fail and rip off, and you wouldn't want to lose a, what, $550 Starlink dish these days? So it's totally fine when you're parked. I wouldn't risk it when you're driving. I wouldn't risk any 3D printed part for a $550 Starlink dish that if it falls off your RV, it probably won't work anymore. So I would do it when it's sitting. I wouldn't bother with it when it's moving, personally. And yeah, low tree branches, definitely a good one. And so we have our styrenes, right? ABS is just, it's the cheapest one, right? ABS is the most common plastic on the planet. It is the most commonly used plastic in consumer goods, in just everything, right? ABS is used all over. Your car's got a ton of ABS. Even my car at 22 years old has a bunch of ABS in it, right? And that ABS is slowly starting to fail. If you all have older cars and your dashboards are starting to really crack, or you see the video of people like smashing their dashboards and their dashboards are just shattering, that's ABS. You don't want ABS. You want to go with ASA if it's going to be in any amount of heat and UV, because ASA is that UV stable. That is an important thing to have. And again, if the price is the same and you don't care about the differences in color, go ahead and use ASA. I see we're joined by Royalty. Mango Jelly Solutions for FreeCAD is here. Hey, late to the party. I'm looking at an outside project and was wondering what materials go for that will survive UV damage. Oh, hey, we were just talking about that. It's ASA. For those that don't know, and Mango, we need to chat. I don't know the best way to reach out to you, but you can email me if you want, youtube@3dmusketeers.com. I want to have you on and we can talk about FreeCAD. Because that would be a fun podcast episode, I think. But if you are wanting to learn FreeCAD, if for some reason you've decided that becoming a masochist is what you would like to do with your life, we don't kink shame here. I want to be clear, that is a actual written company rule. We don't kink shame. But if you do, for some reason, want to learn FreeCAD, I am told, and personally have seen, that Mango Jelly has some of the best tutorials for FreeCAD out there. So there's your free promotion. Go like and subscribe or something. But yeah, ASA. If you want to be certain, just use ASA. You can get away with PETG. And in fact, we've had PLA outdoors for almost a decade now, and it's been fine, right? The colorant will start to fade over time, right? Any colorant will start to fade over time in the plastics, right? So you will notice that the colors of your parts will start to get more diluted. That is just wind, rain, especially if you live in salty environments as well. But UV is probably the biggest damaging factor to plastics. PLA is not UV stable. PETG is not technically UV stable. It is often good enough, but ASA is UV stable. Just be careful when you are dealing with ASA or ABS. They often shrink a lot. And that shrink rate can be a little bit uncontrollable for large parts. That's why if you are going to be printing with styrene plastics, it is best to use a printer with a heated enclosure, or add your own heated enclosure, or do it really jank and use, like, a heat gun or a blow dryer, something to add extra ambient heat to a chamber. And it needs to be fairly consistent. If you can get your chamber temperatures to like 60 or 70 C, you'll be able to print ABS beautifully. But note, if your printer has any printed parts on it, anything above like 50 or 60 C is gonna piss it off. So be aware of that. Heck, even in bamboos, if you print a lot of ABS or ASA, you might notice that the magnets for your front cover come unglued, because whatever glue that bamboo used has a relatively low melting temperature for it. Ask me how I learned. JB Weld fixes it, though. JB Weld fixes everything. But, and then we have like the crazy stuff, right? Polycarbonate, nylon. Nylon is one of the few plastics that I really don't like printing without a filler. Nylon warps so bad. Nylon warps so freaking bad. I do not like it. It's a great material if you have a heated enclosed 3D printer, but very few people have them. Yes, you can go get a Cheaty. Cheaty Tech makes printers with heated chambers. And I think they're good to 60 or 65 C depending on the model, which is fine. But if you're running like nylon, that is on the lower end of where you really want nylon to be in terms of, actual ambient air temperatures. Stay hydrated, damn it. Drink some water. Nylon has the unfortunate problem of being incredibly hygroscopic. It absorbs water faster than it just... God, we can't have nylon in open air for more than about 2 hours here before it pretty much becomes unprintable. There's very little that we can do to stop that. And so often we print directly out of dry boxes. And it's why we want to do this dry box showdown, because I want to figure out the best dry box for the business. And I've got a YouTube channel, so damn it, I can do this. I'm reaching out to Creality to get the Creality one. I think I have most of the others that have been mentioned so far. But yeah, I worry that people will try like a PA12 nylon because, oh, it works great on SLS, which it arguably does. It works phenomenally on SLS. But as a raw filament, it doesn't work very well. You have to overheat nylon quite a bit, and drying at 70°C is a start for nylon. You gotta let it dry for a long, long time. So when we look at what to do with nylon, I say fill it. Add carbon fiber, add glass fiber, add something. Because those fibers, while they don't stop the ingress of moisture, what they do is they keep it from warping as much. I don't know if any of you have ever tried doing two different prints. Same basic G-code, but one was filled and the other one was raw for nylon. Regular nylon sucks. It just warps constantly. Well, when you fill it with a carbon fiber, that carbon fiber or glass fiber, right? Any of the fiber materials keep the material from warping as bad because the fibers do not shrink when they cool. So it keeps the part kind of stuck where it needs to be. And as Seabass says, raw nylon is not very stiff. It's incredibly flexible, like close to TPU levels of flexible, which you can absolutely use to your advantage because that makes it impact resistant. It makes it very, very good for high heat applications that need to have a part that clicks in and clicks out, right? So it just naturally can bend without having a lot of issues. Polycarbonate is, well, similar to nylon, just a little bit easier to print in my experience. We use the Polymaker Polylite polycarb, I think. I've also used the Polymax. I don't know what the differences are. To be quite frank with you, I have no clue what the differences are between the Polylite and the Polymax polycarbonate from Polymaker. That's a lot of polys in one sentence. But I don't know what the difference is. I'm sure that means that the Polylite might have some filler. But I don't know what that filler is or why it matters. And that's where my concern is for people trying to print. If you don't know what's going into your filament, especially if you're a business, then you shouldn't be using it because you can't guarantee the quality of the part that comes out. Let's say somebody ordered a part in polycarbonate and I used some sort of filled polycarbonate and that part failed, creating some sort of injury. That now becomes a legal risk for my company. And if I didn't do my research to figure out that, oh, this isn't pure material, then that's negligence on my side. I don't like that. That's something that I really, really want people to be more aware of. Because I know a lot of you are looking to create businesses with your printers. And to do that, you gotta know what you're printing with. Every time. Diometa says he recommends the Grat Kit filament dryer. It's a cheap and good dryer up to 70°C. Can you DM that to me? Can you DM me a link to them? I'll reach out and see if we can get one. Rose Kidder said same concept with cement. You put fibers to add rigidity and bind to each other. But the same problem exists with cement, that if you don't know what fillers are being added or the purity of said cement and something goes wrong, people can, die. But that is a huge legal risk, right? When you provide parts to people, you are effectively signing off and saying, this is what I say it is. And if it's not, you're at risk of having problems. I'm not a lawyer. I think it's been pretty clear. I'm not a lawyer. I'm not an accountant. This isn't financial advice. And this is a cat. I always move the wrong way for this. This is a cat. This is a long cat. It is a long cat. Shirts coming soon. But yeah, you got to be careful. And it's why, is raw better? Yes, raw filament is better. Even your colorant can add filler that you're not aware of, right? It can be a problem. Berlin asked my opinion on PCTG. I don't hate it. It is a little bit easier to print, but I've never had a project specifically call for PCTG. They will often call specifically for a polycarbonate, where PCTG is a blend. I haven't played with it too much, but that's also because it's relatively expensive, and I've never had a need to play with it. So yeah, most PC you can buy isn't actually raw, as far as I know. Durdackle says, yeah, I agree. Logino says, I wish more manufacturers had easily available datasheets. It's not just the datasheets. I want full MSDSs. I want to know what's in there. I don't care if you're adding talc to your filament, but I need to know that you're doing it, right? I don't care if you call it PLA Plus or PLA Pro. That doesn't matter to me. I don't care what stupid naming scheme that you put on things, but I need to know what's in it so that when we are doing things for companies, we know what's going into it. Because if we don't, we've got a liability issue. And yes, I could say, well, you know, the company didn't say anything about having any fillers. But yeah, it's a weird one. It's a weird one. Because there's no ISO standard for what filament is, or there's not an industry standard. Actually, I believe there is an ISO standard, but there's not an industry standard that the filament industry has adopted. We have a lot of unknowns. And those unknowns are why I want to bring in experts to talk about it that know quite a bit more than I do. Joseph Grider says, what is my experience with PP or polypropylene? I hate it. 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 Did I mention I'm not a fan of it? I do not like polypropylene. It sticks to nothing. What is your bed prep for polypropylene? You know what your bed prep is for polypropylene? It's packing tape. Packing tape is what you put on a build plate for polypropylene 3D printing. It is so stupid, but it's the only damn thing that polypropylene seems to stick to. Why? You know, the worst part is, we have a client that like really, really, really wants polypropylene. I'm like, I'm happy to do it, but it's going to be like 4x the cost because I don't want to deal with the BS. I'll give you PETG. It is close enough, right? For their needs, it's close enough. But as it is, 3D printing isn't going to give you a like sample to a injection molded part. So it's for show, not for go. And yes, Seabass says it's because the tape is made of polypropylene. Yes, that's the joke. It's because it's made out of polypropylene. But yeah, polypropylene is rough. I don't like it. I find it polypropylene, you know what polypropylene is great for? It's cleaner filament. That's pretty much what most cleaning filament is made out of. It's polypropylene. So if you want to go get a roll of polypropylene and make your own cleaning filament, you can do it. So that's about the only reason I would ever recommend buying polypropylene, unless you have a specific use case for it. Polypropylene is nice in that it is a food grade plastic, but your printers aren't food grade. Stop it. And I know, oh, it's the food talk. Look, all right, do whatever the hell you want. Because at some point, I tell you all that resin is toxic so many times and none of you listen to me anyways. Or, a lot of people don't listen to me and they end up getting hurt. I still don't believe that you should be eating food or drinking water, anything out of 3D printed parts that are not properly, post-worked to be food safe. It's not worth getting sick, man. It's not worth getting sick. Anyways. Durdaka says, I think Berlin meant PCTG, the copolyester, similar to PETG, not anything polycarbonate related. Oh. Well, then I don't know. I don't think I've ever used it then. I'm sorry. My bad. I didn't know that. Steven Z is asking about my thoughts on the Fiberon filaments from Polymaker. They have a PETG ESD for one that is interesting. I am glad to see another company taking exotics reasonably seriously, because previously there's only really one decent option out there until Fiberon for decent exotics, and that's 3DX Tech. pretty much nobody else makes exotics like that. 3DX Tech is known for making exotic filaments. Do you pay for it? Absolutely. I did recently find that Atomic makes fire retardant ABS, so good job. And I do happen to really like Atomic's carbon fiber nylon because they make it in different colors, which is super cool. But 3DX Tech has always been my go-to for exotics, right? My normal stuff, I go to Printed Solid for, who, of course, sponsored the filament giveaway in the pinned comments. If you want to win some filament, go get that. Go sign up, and we'll choose a couple of winners throughout the episode today. But I'm glad to see another company caring about it. Like, their PPS CF is a very cool material. I think a lot of it is kind of pointed toward the 2A community, which is fine, right? They know your market, right? If your market is a lot of people that are in the 2A community, as a business, well, you know, you can choose to work with them or not. But if you don't work with them, they're just going to find somebody else to go to. So you might as well work with them. There's really no shame in doing it. But I will be looking at them for, for exotics. My concern is that it's not made in America, and a lot of the clients that we have that require these exotics also require made in America. So it's a bit of a moot point for us. But it is something that I'm glad to see another company actually care. And I'm interested to see how they tend to expand the Fiberon series. So I don't know. I will have to reach out to the 3D Print in general and see, because I think he's my contact now at Polymaker, but I don't have any Fiberon on the way. There has not been anything like that, unless they've sent it to me without my knowledge. I have not ordered anything from the Fiberon line at this time. So then we start to look at fillers, right? One of the most common fillers. I guess I should explain to it. It's firearms, right? 2A Second Amendment's right to bear arms. So if you ever hear me say 2A, it's I'm talking about the Second Amendment and firearms. So people that are 3D printing firearms. Love it or hate it, there is a reasonable portion of people that bought 3D printers specifically for this purpose, and for companies who just ignore it is ignoring target markets. So it's business. It's business. First time I've heard the expression 2A. Oh, okay. I've used it plenty of times. But all right, I didn't know. I figured that was like a well-known colloquialism, but I guess it's not. I'm sorry. Zombie Hedgehog says, I need to build a printer to try PPS. I've tried PPSU. I've never tried PPS specifically. I have some PPSU. It's great material. In fact, you can print it on consumer-grade machines, but you will need a diamond nozzle, because it's the only way you're not going to get into thermal runaway territory, because PPSU really wants to be like right at that 300C mark. Or, you know, just a high temp, a printer with a high temp nozzle. That would be fun. I definitely haven't been working on something like that. Exotics to me are well outside of the range of most companies and most people, right? The vast majority of people, they're going to look at an exotic being like a silk filament. And silk filament is filled in its own rights. And if you've printed with silk filament, you know what I'm talking about. It's crazy freaking weak. Why is that? Well, it's because it's TPU, right? I know for a fact that silk filament uses TPU to be silky. Why? Because it's what we used at Printed Solid. Now, we were open about it. We can't share, you know, the actual rates with you, like how much goes into what. But it is TPU. I promise you it's TPU. And a bucket of TPU feels really cool when you stick your hand in it. I'm not going to lie. It feels super cool. But yeah, when you have TPU and you're printing it at PLA temperatures, it doesn't get liquidy enough. And those two materials don't really like sticking to each other. And so you end up with a part that looks pretty, but as far as mechanical stuff goes, is completely useless, right? That's why silk is great if you want something that is for show. It's not for go. Do not ever use silk filament in an instance where you need it to not fail. Silk is very kind of dangerous. Don't use silk filament for like mechanical stuff. Diomedes says, but silk PLA is abrasive AF. No, it's not. It's not at all. Silk is not abrasive. Yeah. Silk is a great accent on a multi-material print. Totally agree. Totally agree. Totally agree it is. Rose Skinner said, I hate printing silk. My filament I print out is 180. Silk I have to use 215 at the lowest. Yeah, you do. Silk needs a lot more temperature because you have to be able to melt down the actual TPU in there. So, yeah. And literally, like when we made that Jesse elixir, which I still think should be called Silver Fox. I want it to be called Silver Fox. It is literally PLA, TPU, colorant, mix into machine to extrude. That is it. So Zerna says, do we know for sure that all silks are TPU enhanced? No, we don't. We don't know that for sure. However, I think it's relatively fair to say that's what the vast majority of companies are using. TPU CF. Well, that is a complete and utter waste, but I'm sure someone does it. In fact, I've got a roll of filament here somewhere that's cord filament. It's got a different material on the inside than it does on the outside. We'll be doing a video on that at some point soon. Oh. Zombie did get carbon fiber. Why would anybody... What's the point of a carbon fiber TPU? Honestly, there's no point to a carbon fiber TPU. Why? What's the point? Ugh. Anyways. Difference Engine says, have you had any experience with bamboo running PVA support material? Is it easier just to use something else? I don't like using single head multicolor units when you're dealing with dissimilar support material. If you're going to do it, I would use PETG because it's cheaper and it's way less work to deal with, and PLA and PETG don't mix. But the problem is you must be very, very, very certain that your purge rates are correct. Because if there is any mixture between those two materials, the mixture area where all of that occurs is going to be incredibly weak and your part quality will dwindle drastically. It's why I have a tool changer. I have a tool changer because I want to play around with dissimilar materials, but I don't want to deal with purge volumes. So, yeah. The point is because Zombie said it was at Matter Hackers. I had to get some. That's fair. Fine. Y'all are weird. TPU is actually a great heat conductor. Is it? I think it's a great heat insulator. I don't know about conductor. I guess CNC Kitchen just released a video on flexibles, including TPU CF. This is what I get for not watching YouTube this morning, I guess. It's been a busy morning. It was a late night and a very busy morning. That's the top of the hour. I say we give away a spool or two. You guys have until 1:05, or just you have one more minute to enter the giveaway. I'll close the entries for a little bit. We'll give away, I don't know. Let's give away a spool. Just one spool. I don't know. Let's give away a spool. Rules are on the sheet, pinned in the chat. Go ahead, fill out the form, get you some filament if you win. Until 1:05. Afterwards, we'll wrap up filament and then we'll go into resin a little bit. I think that would be fun. Resin, I don't know a ton about. I know that it's toxic. Resin is toxic. We know that. But, yeah. Yeah. All right, it's 105. I'm going to turn off the form a little bit. Only 30 respondents? That seems a little low. But whatever. All right, let's get this. Let's get this happening here. Today is the 28th? Yeah, today's 28th. John Olson, you were the first one. I'm going through all the names in my list here. All right, let's go ahead and get into the wheel of names. Shuffle a few times. Click to spin. I have to make sure that whoever wins hasn't won in the past months. That's the first thing we got to do. So let me see here. They have not. Let's see if they're here. Difference Engine, are you in the chat? Are you in the chat? Difference Engine. I see Difference Engine in the chat, but they haven't noticed that they've won. Difference Engine, you have won a spool of printed solid Jesse Filament. Reach out to me via email. Or actually, no. Reach out to me via Twitter or Discord. And we will get you that roll. I can see you in the chat, so I know you're there. I see you have won a roll of Filament. Congratulations. You get a roll of Jesse PLA or PETG, because it's the only two materials that Jesse has right now. Shipped directly to you, totally for free, courtesy of Printed Solid. Gotta love Printed Solid. Check them out, printedsolid.com. I don't know. They just gave me a bunch of Filament to give away. They didn't tell me I actually had to do any ad reads for it, but it still feels better that I do, because I like their Filament. So thanks, Printed Solid. All right, let me open the form back up. There you go. Discord, I'll send you a message. Cool. It's at 3D Musketeers on Discord. So this is the problem, right? We have all these different materials coming out, but very few companies are actually giving us the metrics that we need, right? So a carbon fiber PLA, carbon fiber PETG, carbon fiber nylon. Just carbon fiber nylon, because that one's the picky one. Well, if it just says it's carbon fiber nylon, what is it? What is the percentage of carbon fiber? Is it long strand? Is it short strand? Is it just carbon fiber powder? What is it? Because all carbon fiber filled materials are not made the same. We've played around with really long strand, like multi-millimeter long strand carbon fiber, and it is super cool. Super freaking cool. But it does have a tendency to, you know, be a bit of a challenge, right? Because even from, like, manufacturing from one to the next, you can be, you know, plus or minus a couple of percent. It's why we chose 3DX Tech for all of our exotics, because they give you the percentage of carbon fiber. They tell you if it's a 5, a 10, a 15, or I think they go up to 20 or 25%. And that's a lot of carbon fiber, right? If you're going anything above 15% carbon fiber, be a little bit worried about the actual, like, strength of your parts. You want to be careful with that. Glass fiber, to me, I actually prefer glass fiber over carbon fiber. I think it looks nicer. I like the little shines that you get with the glass fiber. But glass fiber has a particular bad time of, you know, itchiness. Same thing with carbon fiber, but carbon fiber is easier to see because it's black. At least on my pasty-ass white skin. But yeah, you know, I've quite enjoyed 3DX Tech because they give me all of those specs. I haven't checked to see what Fiberon does and doesn't give, but I hope that it gives those specs, because those specs are going to be incredibly important for us to really consider it as a potential for our shop. I know the average consumer that Fiberon is likely going after might not care, but the business class consumer, the ones like when I order carbon fiber, I'm ordering 10 to 20 kilos at a time for most products. Like the fire retardant ABS that we just did, that was a 20 kilo order, right? and a big check that went along with it, which I'm very happy about. But, you know, we're not ordering 1 or 2 rolls at a time. We're ordering a bunch. So I hope that more companies do it. But we have this kind of unknown of, is it pure nylon? Is it nylon mixed with something else? Is it pure PLA or is it PLA mixed with something else? It is this big question of what is it that I'm actually freaking buying? Especially from these mega massive manufacturers. What am I actually buying? And if they just have, you know, oh, it's 80 to 90% PLA and 10 to 20% proprietary blend, I can't trust it because I don't know what it is. As much as I love Polyterra because it looks nice, it's soft, but because it's soft, it's really, really weak. Polymaker is apparently going to be making a more, like, stronger Polyterra. But it's like, oh, I like Polyterra. I also learned the hard way that Polyterra is more dense than regular PLA. It is listed on the product's description page, but I never thought to actually check it until I'm like, I think the spools are low. And they're like, no, you're an idiot. It's just higher density. I'm like, oh. Okay. Matt says, how much talc is in Polyterra to make it that soft? I don't know if it's talc. I think it's PHA. I'm not 100% certain. Only Polymaker will know. And unfortunately, we as the consumers don't know. And that means that that material, while it is very pretty, it falls into the same category as silk for me. It's too weak to be anything that I can take seriously when it comes to additive manufacturing. It is for trinkets and toys and fun stuff. It's not for go. It's for show. And it's a bit of a bummer. You gotta have consistency. Consistency is very key. And, you know, being just being consistent and being open about the materials, I think, is incredibly important. Although I feel like either, I know Zombie might know. Zombie, do you think that Nick would actually talk about that stuff on air? I don't think that he would. If he would talk about that stuff on air, I would have him on. But I don't think he would talk about that stuff on air. Mitch from Polar 3D wants to talk about that stuff on air, but Polar doesn't really make a lot of blends. I know that Polymaker does. I don't know if Nick's going to want to talk about that stuff on air because that could viably be giving away some of the secret sauce, right? And we're not trying to do that. We're not trying to do that. Could we demand an MSDA, material safety data sheet? I think you're thinking MSDS, material safety data sheet. Material safety data sheets are great, but you can still list something as a trade secret. Right? You can say it's safe, but it's a trade secret. We're not telling you what it is. A TDS, a technical data sheet, would tell you a lot of what you would want to know without having to give away those trade secrets, but still, I don't know. Resin is toxic. There'd be like an editing thing that occurs here. I can't do it live. It'd be funnier if I could, but I can't do it live. Weird, but, you know, whatever. That's life. Resin has all these different variants as well. We, personally, structured around Soriatech. Soriatech, which is also PO Poly, for those that didn't know. I didn't know that for a while. But those two, they're the same company. And we structured around them because, as far as we're aware, they don't change their formula very often, right? We have these water washable resins that companies don't talk about are still toxic to your waterways, right? That resin is still toxic. It will still give you chemical burns. And we've shown you plenty of times on Print Fix Friday that resin will burn your skin given a long enough exposure. The resin itself is actually not the problem, I believe. I believe it is the UV curing agent that makes it so kind of painfully dangerous to humans. It's a contact allergen. So you really need to wear proper PPE. Now, we could get into a discussion about PPE for filament. I'm waiting for UL to publish a paper on it. They haven't yet published their findings, but UL has been doing testing for years on this. And if they did do testing and they published it, I missed it, and I'd like to know. But resin, because the machines are so cheap, a lot of people opt for resin, especially the D&D, the Warhammer people, right? They love resin because it fulfills their needs for 3D printing. And I don't blame them. If I was in that industry too, it would completely fulfill my needs as well. So there's no reason to look elsewhere. But if you don't know about the precautions regarding skin contact, eye contact, fluid contact that is potable, then you don't necessarily know about the dangers of resin. And these manufacturers don't put big enough warnings on their bottles. I just want to make sure this bottle should be clean. Yeah, it's clean. Like, this is a bottle of Ceratec resin. There's your warning. It'll focus eventually. Your warning is so tiny. It says, avoid contact with eyes, mouth, and skin. Wash with warm water. Contact medical professional if ingested. Best cleaned with 95% ethanol. This is the Ceratec Blue Tough Nylon Black. This is a bottle that we use. It is one of my favorite UV resins personally. Yeah. It's a good resin, but it also pretty much hates anything but ethanol. It does not wash off in water. It doesn't wash off with, well, kind of washed off with isopropyl alcohol. Ethanol, otherwise known as denatured alcohol, is the best way that we've ever found to deal with that. So, something to be aware of there. Rose Kindred says, do find out materials of prints. Does anyone have a scanner they recommend? I found one, but it is about $3,000. Rose, are you in our Discord? Our Discord is going to be the best place to ask that because we have a bunch of 3D scanning people in there, myself included. $10 tier or higher gets you in if you're not. But we have to know about the project to be able to recommend it. So, Brandon says they're currently about 30 minutes behind. You should fix that. But what is the difference between glass and carbon fiber? I prefer carbon fiber, but my business partner wants glass. It's the fibers made of carbon or fibers made of glass. That's the difference. It's what the fibers are made out of. Carl's Pena says, well, you don't have to drink it. It's a matter of taking appropriate precautions. I don't disagree with you, but I feel in 3D printing in general that most manufacturers do not provide you with the ways to remain safe. They don't tell you what to do. There isn't literature out there that comes with the machines that is like look at a pack of cigarettes and the warning on a side of a pack of cigarettes, right? Especially in the EU and the UK. They go hard in the paint for that kind of stuff. I absolutely want to see more stuff like that for resin 3D printing. So, yeah. Sardonic scanners have more of a detector. It scans the resin in the print, so recycling the prints based on... Oh, okay, so you're looking for a mass spectrometer. I have no clue. No clue. I guess, did UL actually publish something? Yeah, they did. But specifically... Okay, so they published, and Madcat threw it in the chat. So they published something about safe use for higher education. That's not what I was hoping for, but hey, that's a start. Maybe a usage or precaution sheet for each product, Carl says. Maybe, right? I don't know. It's like this weird problem when products get into the commodity stage where they become so accessible, but the education for it is nowhere near as accessible as the materials. So the education gets missed and people end up with chemical burns. And I don't want that, right? Get a pair of chemical handling gloves that go at least halfway up your arm. I understand that you're going to end up with, less than ideal dexterity, but use that for your first clean cycle dry off the part. If it's still shiny, go back into a second rinse in a second bucket, like the 2-bucket method for washing a car. It's very similar. I use a 3-bucket method personally for resin: a dirty, a semi-dirty, and a final rinse that is a clean bucket. And it seems to work very well for our actual use cases. And yes, like John Stern says, at some point you will spill resin. It's not a maybe you will, it's you will spill resin. It will happen. And there's no good way to stop it from happening. Yes, silicone is a great like prep surface for a table, because then you just use a UV light to cure it, and the little bit pops right off, and you can throw it away when it is fully cured. But if it gets onto your clothing, right? If you do need a new shirt, merch coming soon. We might have to go to DTF. We've been using DTG printing, but I'm concerned that it's not. My worst nightmare is coming true with the merch. That we are basically ready to launch the store, but the product started to fail on me way before any of the other products have failed. And I don't know why. So that's very upsetting. Very upsetting. David Hunter says PVA, how toxic is it? It's Elmer's school glue. It's not toxic at all. I mean, don't drink a ton of it, but it should be fine. Zero says, any idea of how toxic resin is compared to common solvents like acetone or others? Acetone is not all that toxic. It's dangerous because it's very thin, but people get acetone and brake parts cleaner on their hands all the time. Hell, I'm guilty of like, oh, you know, I'm covered in oil. I just hit my hand with brake parts cleaner. I'm guilty of doing that, right? You shouldn't do it, but I'm guilty of doing it. Only once or twice, but still. I am not guilty of getting resin on my skin. I've never had heavy exposure to resin. I've gotten little droplets here and there, and when I notice it, I've got clean alcohol sitting around and a paper towel, and I just, you know, kind of over a bucket and then wipe it away, right? It seems to work well. But we have a concern about the safety. And so let's move away from the safety and move into the actual materials. Resin is often doped with different types of chemicals to give it different features. And hilariously, the resin itself, right, that people use, they're doping it too. I have a bottle of Tenacious. I have never printed with pure Ceratec Tenacious. It's a flexible resin. Never printed with it pure. I pour it into all of the resins that we have. We use measured amounts, so it's, you know, a good mixture, and that gives added flexibility to regular resin parts. It also helps that when you heat it with a heat gun, that it gets extra soft, and you can easily peel off support material without it like actually leaving big divots on your parts. But when we look at like some of these really crazy resins, like Atlas has some cool resins. I don't know how public people have been about it, so I don't know if I can talk too much about it, but Atlas 3D has a lot of cool resin. So if you're looking to play on the upper echelon of what resin is, Atlas 3D and Mayer Makes, they're probably the two big, like, we make dope resin companies out there. And I have some engineering grade Mayer Makes stuff, and I want to test to see if it is actually bulletproof, but my local range won't let me do it. So I'm a bit bummed about that, because I want to just print a brick, right? I have old Elegoo, like Gen 1 Elegoo Mars printers that I'm happy to destroy the screens on to print a brick and see what happens. So no. Tundi says they have ventilations and an air purifier. That is always good. The fumes from resin are dangerous. And even the fumes from the alcohols, like denatured alcohol, which is ethanol, will smell like you're cooking moonshine, okay? It's got that corn smell, if you will, right? It just gives that southern drawl when you're talking about it, right? And you got to make sure you're venting that out, right? Or have a good way to filter it. Often carbon filters can do a fair bit for the smell. I don't know how much they do for those airborne particles. So, you know, take that with a grain of salt. Having air scrubbers can be incredibly valuable. We will be doing a video on one at some point. The box fan with a bunch of air filters on it. It's cheap as shit, and it works phenomenally well when we're looking at, like, you know, viability for actual air filtration. I've used them in wood shops. They work great for that kind of thing. Johnson has moonshine. Is this the 1920s? Hell no, man. Dude, I can get some good moonshine locally. It's really good stuff. Like, you don't ask a lot of questions. You pay in cash. It's great stuff. And I'm not a big drinker, but this area of Florida is known for kumquats. It's a weird, like, citrus orange thing. But kumquat moonshine is phenomenal. And there are, you know, some guys that still kind of definitely make it totally legally, because otherwise it would be very illegal to do it. They make moonshine in distills, right? And they do it themselves. But yeah. And John's fun fact, bad tasting moonshine is why cocktails were invented. That is correct. Yeah. John Stern also says he uses a two bucket method for car washing, one for shampoo, one for clean water with a bottom grid. Amen to that. For rinsing the sponge after each wipe. I think it's very similar for 3D printing resin. Denatured alcohol is pretty cheap. We got it from Rural King, which is like redneck Walmart. And if you think Walmart could get more redneck, welcome to Rural King. And it's like $20 a gallon, I think is what I paid. And it's not that bad. I mean, that's pretty decent considering most people don't need more than a couple of gallons on hand. But do note that you will need to slowly add more alcohol as it evaporates and as it gets saturated. There are ways to clean that alcohol. There's some chemicals that you can use. Would you guys like to see a video on that? So you can precipitate out the resin by adding chemicals to alcohol. I'm not a chemist, and I worry that being not a chemist has some potential problems. If you pay taxes, it isn't moonshine. I believe you have to have a license for it as well, but I'm not a lawyer and I don't understand that stuff. So, yeah. Let me see. Tony D says, I'm a bit extreme. I also have an outside air pumping into my basement as I vent air out also. That air will find a way in. You can't remove air from an environment and it not find another way in. There are tons of air leaks in your house, whether you like it or not. And it's why, you know, when you turn on vent fans in bathrooms, that all of a sudden the air doesn't get sucked out of your house. Hot air or humid air or whatever is coming in through other areas, whether it's small cracks in windows, small holes in insulation, right? There are ways that air permeates. Having a fan to blow outside air in as you're sucking air out does help, because it's a guaranteed path for it to flow through. But you want to make sure that the inlet for air and the outlet for air are not very close to each other, because otherwise your system for sucking air out is just going to suck from the inlet for air in, and it's not going to actually purify the air in the room itself. So, Rose Kindred said they use a 4-bucket method, which is dirty resin, cleaner resin, simple green, and water with an old water pick. Oh, now that's something I didn't think of, using a water pick, but I guess I'm a little bit worried about that. But I guess once you're through, you know, dirty resin or a dirty alcohol, clear alcohol, and the simple green, it should be pretty clean by then. And yes, Ember Prototypes, as Shannon is saying, had a recent video on how to clean alcohol. It was pretty cool. It was. Had I known that Phil was going to make that video, we probably would have like waited to talk about Ember Prototypes a little. I gotta have Phil back on to talk about resin. I don't know. Phil was a cool guest, but I guess I found out that he wasn't feeling very good that day, and he didn't want to cancel on me last minute. It would have been totally fine, Phil. It would have been fine. I feel bad that you like were hanging out with me while you weren't feeling good. Sorry, boss. But yeah, acetone is surprisingly low in toxicity, as SoundSpark says, so it's a very low bar compared to regular resin. Yeah. I want to get Mayor Makes and probably Goobertown Hobbies on here to talk about it more, because I am not the best person to talk about it. But that's okay. I don't have to be, right? I know enough about the plastic side of it. And the big thing is with resin, before you throw it away, cure it, cure it, cure it, cure it. Like, I've had resin parts curing outside for over a month. I'm in no rush to get rid of them. I want to make sure they're properly cured. Oh, yeah. Matt has, you know who should get? Nile Red. Dude, you're right. I should. Nile Red would be super cool to be on here. All right. Mad Cat. Let's see if we can find a way to reach out to Nile Red. That would be super cool. Yeah, because he's like proper chemist. That'd be so cool. Anyways, I'm like now geeking out that I could get Nile Red. That'd be awesome. But yeah, that's really it, guys. Let's give away another spool. Why not? You guys will have another couple of minutes to get entered to win a printed solid Jesse roll of filament, courtesy of Printed Solid. Big thanks to them for allowing us to do this crazy thing. We give away some filament. And those of you that have won filament, if we haven't spoken yet, if you've won filament and we haven't spoken yet, you don't need to enter again. No, if you've already entered once, that's fine. If we haven't spoken yet, please reach out to me again, because I've likely missed your reach out. But I'm fairly certain, I think there's only one spool left that I don't have an answer on, that I've already reached out to the person. So, yeah. I prefer the raw materials, right? I want raw PLA, I want raw PETG. Although nylon, again, is one of those where I want it a little bit different, right? I want some filled. I do like filled materials. Like, here's... I can show this side of it. Like, this is carbon fiber PETG, but it's been blasted. We blast a lot of our carbon fiber stuff to seal it before we send it to clients. But that is also printed on a diamond nozzle, and I know enough about it to know that I'm pretty happy with its safety. David Connor Shiver says it was me, never got a return email. All right, then re-email me, because I've likely missed it, or it went to spam. If you don't mind, include a phone number in there, so I can just give you a call on the phone and we can just figure it out there, because that would probably just be easier. Sometimes my emails get tossed into spam because the 3D Musketeers domain, because it starts with a number, for some reason upsets things. This was news to me. But all right, guys, until 1:33, so you have less than 60 seconds, then I'm going to close the entries, and we're going to let you get on with the rest of your day. We're going to send you over to Steve Builds. Hopefully, I don't screw up again and send you over to an old Steve Builds video. Hopefully, I send you over to a new one, because that is funny. That happened last week. I feel bad, though. Seabass says there are some materials that are a pain in the ass to print raw. Some manufacturers add stuff to make it printable. That's fair, but should we need to print that? Like, PET, for reference, is difficult to print raw, so we add glycol to it. But that is a standardized material, right? PETG is a standardized material, even in injection molding. So do we consider that a weird blend? I don't know. Oh, they just made the same comparison that I did. All right, I'm going to shut off the giveaway. I only got 6 more people. Come on, man. Y'all are rough. Y'all don't want free filament? It's free filament. Come on. Where's my A to Z? There's A to Z. Okay. Let's see. I got to start with that. Go down to there. Copy it. Oh, that didn't work. Copy. Hello? Interesting. I don't know if I'm able... Oh, hold on. Only 6 people entered, so I can just get their names in. So this 1, 2, 3, 4, 5, 6. Right? That is really, really weird. That worked. Just make sure... Yep. I have someone in there twice. Shuffle a few times. Let's give away a spool. Let's give away a spool. Where's my wheel? There's the wheel. All right, let's see if this person is won before. It's always hard to find people's names in here. They have not, and they got the math right. Nice. All right, Joe Rust. Joe Rust, are you in the chat? Are you in the chat, Joe Rust? Are you in that chat? Joe Rust is in the chat. Joe Rust wins a roll of filament. I see him. But doesn't yet. Hasn't yet figured out they won. Let me see. I'm gonna set up the redirect here so we can go over to Steve for you. All right. Rust-filled filament. Give me one that's rust, and then give me another one that's powdered aluminum. The OGs know why. All right. Well, cool. Thank you, everyone. I need to mark Joe Rust as a winner. So here's my kind of thought. I'm just going to do it every month. So you can win once a month. I don't want to have like a rolling 30 days. So I think next month we're just going to start a new sheet. And if your name is green in that sheet, then you can't win again. I feel like that kind of works. But yeah, it is. There was a YouTube delay. It was funny, of how all that worked. But yeah, congratulations, Joe. Send me a DM on Twitter or Discord, and we will get you that roll of filament. Huge thank you to Printed Solid for that filament giveaway. Check them out, printedsolid.com. They're going to be making Prushiment soon, which is super awesome. I hope that lowers the barrier to entry for Prushiment in the United States. I am really looking forward to that. So, anyways, y'all, I'm going to get out of here. I like it raw as far as filament goes. That's all I have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, leave a like, get subscribed, and keep making awesome. Have a good one.